All right, so we are moving on to factoring. And so we're looking for a common factorizing, a common factor. Factorizing, that's a British term. We always just call it factor where we are. But anyhow, the act of factoring is factorizing.
Is factorizing, which you'd spell with a Z as well, right?
All right, so, but what is a factor, Mr. Cole? We are talking, making jokes about factorizing stuff, but what is a factor?
Okay, so a factor is something that goes into a number, right? Or so it goes in exactly.
All right, so if I have 18, what's a factor of 18?
So you've got 1 and 2 and 3 and 6
and 9,
9
and 18. These are all factors. They divide exactly into 18. So if I want the greatest common factor between 12 and 16, I can think about all the factors of 12, all the factors of 16. So this is 1, 1, 2, 3, 4, 6, 12, and 1, 2, 4, 8, and 16. And I want the greatest common factor between those two. And that is going to be
the 4.
The 4. And as you do this, you get better at doing it in your head. You don't have to write the factors out all the time. But if I think about 27 and 36, the greatest common factor there?
Well, they're both in the 9 times table. That's
Exactly.
how I do it, I think.
Ah, you think about 9s. Okay, I pull out a 9. That is the biggest common factor between those.
Yeah.
Okay. So if I have this scenario, my factors of 9x squared and minus 6x. Well, my factors of 9x squared are, what are they? They are
It's going to be a lot.
3x and x and 3. That's what multiplies to get 9x squared. Here I have a minus 2 and a minus 3 and an x. So if I take out the largest common factor here, that's going to be a 3x's in common here and a 3x in common here. And so I end up with a 3x is the greatest common factor.
Okay.
And so a little while ago we simplified this by multiplying. And when we do multiply it, we get 9x squared minus 6x. So the greatest common factor is 3x, which was here. When I pull out that greatest common factor, when I pull out that 3x, if I'm going to go backwards, I'm going to end up with, I ask myself, what times 3x gives me 9x squared? Well, that's a 3x. And what times 3x gives me a negative 6x? That's minus 2.
Okay, so it's like the reverse of expanding brackets, right?
Right, we're going backwards. Opposite of expanding is factorizing. Okay, so let's try and factor the following here. I think about these two terms, and I think what's common in here? Well, between the 2x and the 6, I know what common is. A 2 is in common in both those. This doesn't have an x. And so when that's the case, I think what times 2 gives me 2x? And that's x. And then I think what times 2 gives me 6? And that is 3. So I'm going backwards. If I want to check it, I multiply it back. I go 2x plus 6. This is my check. The blue here, this is the answer. This is the answer. This is my check.
That's lovely writing, by the way.
Oh, why, thank you. It's not quite perfect, but it's getting there. So if I look at this one, what's common between 10x and 15y there, Mr. Cole?
Okay, so it's just 5. There's no common letters, no?
Right, so 5 times what gives me 10x?
So 5 times 2x.
Okay, and then the same thing here, 5 times what gives me 15y?
That's 3y.
Okay, if we do a check, I'm going to go here, that is 10x, and I go here, that is plus 15y. If this is the same as what you started with, you got it correct. And then finally, the last one for C part.
Okay, so we got a common letter this time, which is M, right?
And then I'm left with?
So 2n, add 1 Those ones seem to be quite tricky sometimes, don't they? When it's a 1.
All right, because if you don't put anything there, then you won't know to multiply. You're gonna, okay. You can check it quickly in your head. 2mn plus m. Looks good to me. Let's try a little bit more challenging ones, perhaps. Let's try this one now. What's common between negative 4a and negative 8?
We could take out negative 4, right?
I like the negative. Pull out the negative. So negative 4 comes out, and I have an a here.
And then just times, we're going to times it by positive 2, so it's in the brackets it's just a add 2, right?
Right, because negative 4 times a positive 2 is negative 8. Be careful of your positive and negative signs. Let's just do a double check on this one. So I do this, I get negative 4a. I do this one, and I get a negative 8. This one is negative, correct. Hooray! Oh man, look at this one. This looks killer to me. I have 8m squared n, 6mn squared, and 10mn. If I look at the letters, there's an m and an n, an m and an n, and an m and an n. So I know m and n are going to be common.
Okay, and then they all divide by 2, right?
Right, so I can pull out the 2. So 2mn times something gives 8mn squared. What's that going to be?
Okay, so we're going to have times 4m.
Okay, keep going there.
Okay, times 3n. And finally add 5.
Okay. I think we should check this one just to make sure. That is a 4 times 2 and 8m squared n. This is a plus 6mn squared plus a 10mn.
Okay. There's probably another check that you should do as well, just to look at what's in the brackets.
Yep.
And just see if there's any common factors there. Because sometimes people just take out maybe the 2 and the m, but forget the n.
Oh, that is
so
good.
That stays in the brackets, right?
Right. So you're trying to say if I had just pulled out 2m,
yep,
and I had then
so
mn plus.
So you got the 4mn.
Oh, sorry, 4mn plus 3n squared.
Yeah.
Plus
5n.
5n. If this was the case, it's still algebraically correct, but it's not fully simplified. You see there is an n here, here, and here that we have to factor out.
Okay, so it's factorized but not fully factorized, right?
Exactly. All right, you're just not done the problem. You're just halfway through. All right, oh lordy, here we go. Lots of numbers and letters going on here.
Okay.
Let's look at the numbers first, shall we? In common here is going to be a 4. The letters, I have a's. I have 3a cubed, a squared, a. So a is the largest. I can pull out and still have some left over. B to the 4th, b cubed, b. So I can pull out a factor of b. And then c to the 7th, c cubed, c squared.
Take out the c squared, right?
Take out the c squared. So it's actually the lowest exponent that's common between them all. So now, going backwards.
So we got 3.
3, keep going there.
A squared, b to the 3, and c to the 5.
Right. Add exponents together.
Okay, and then what have we got? Add 4a b squared c, and then take away 2. Just take away 2.
Take away 2.
Yep.
Okay.
Okay.
Sounds good.
Yep,
Should we check this one, or do you think they can check it themselves?
I think they can check that one themselves. Let's finish this one, I think.
Okay.